Hello guys, today's session we are going to discuss about the calculation of moment of inertia of the given T section which is shown in figure about the x-axis which passes through the center of gravity of the whole section. Here the given T section consists of two rectangles. Rectangle 1 with the dimension 200 mm and 50 mm. Rectangle 2 also with the same dimension 200 mm and 50 mm. Here, before discussing about this numerical, some basic formulas or the fundamental concepts to calculate the moment of inertia, such as parallel axis theorem and all, we will discuss. The formulas used in this numerical. Here, we are going to calculate the moment of inertia with respect to the x-axis or horizontal axis passes through the center of gravity of the whole section. So, first we need to calculate the center of gravity. For x-axis, we have to calculate the y bar. The y bar means the distance of center of gravity from the reference axis. The reference axis means for a whole section or a composite section. For y bar, the reference axis will be the bottommost line. For x bar, the reference axis will be the leftmost line. Then the parallel axis theorem. What is parallel axis theorem? Here, you can see a rectangle is given. This is the center of gravity of the rectangle. The dimension of the rectangle we are going to take as B and D. B is the linear dimension breadth. D is the vertical dimension depth. Here, we know that the moment of inertia of the given rectangle with respect to the horizontal axis x, which passes through the center of gravity, that will be BD cube by 12. That means IG. But if you need to calculate the moment of inertia of the rectangle with respect to a parallel axis AB, which is at a distance h from the axis x, which passes through the center of gravity, then we can use the parallel axis theorem, that is IAB equal IG plus AH square. Here A is the area of the rectangle. Then basic formulas of moment of inertia of the rectangle about x-axis, which passes through the center of gravity. That means horizontal axis. That will be BD cube by 12. Same, the moment of inertia of rectangle about y axis. That means the vertical axis which passes through the center of gravity, that is dB cube by 12. These are all the basic formulas or fundamental concepts which we are going to use in this numerical. Now we will go to the numerical. As we discussed earlier, first we have to calculate the center of gravity. Okay, calculation of center of gravity. Already we discussed the formula, that is y bar. Here I just write the formula for y bar, that equal to a1 y1 plus a2 y2 divided by a1 plus a2. So these a1 y1 a2 y2, that details and all we have to calculate. So first we will calculate for the rectangle 1. The rectangle 1, the area. We know that the area of the rectangle is A1 equal to A1 equal the breadth into the depth. Here the breadth will be the linear dimension and the depth will be the vertical dimension. It is 200 into 50. If you calculate the area, you will get 10,000 mm square. Then y1. Actually here, what is y1? Guys, here the bottommost line, as I mentioned earlier, the bottommost line will be the reference line. Okay, so this will be the reference line. Okay, this will be the reference line to calculate the y bar. From the reference line, we know that the CG1, what is the distance from the reference line to the CG1? Okay, that is actually y1. Okay, this distance is actually the y1 from the reference line to where is the center of gravity, CG1. That means center of gravity of the particular rectangle. Thus, from this baseline or the reference line to here, that will be 200 mm, and the remaining dimension will be 50 divided by 2, that is 220 mm. So here we know that the y1, the distance of center of gravity of the rectangle 1, CG1, from the reference line is 200 plus 50 divided by 2. This 200 is from the baseline to here, and the remaining dimension will be 50 divided by 2. Okay, so here as per the calculation, we will get this will be 225 mm. Now the same thing we have to calculate for rectangle 2. Okay, the rectangle 2 also with the same dimension. So the calculation procedure is very easy. Here A2 also same dimension as I mentioned earlier. So 200 into 50, again we will get 10,000 mm square. Then the y2 is the distance of the center of gravity of the rectangle 2, which is mentioned green in color, that is CG2, from the reference line. It means that from here to here, from the reference line to where is the CG2, that is the center of gravity of the rectangle 2, that is y2. Okay, so here this y2 will be 200 divided by 2. It means that is 100 mm. So now we calculated A1, Y1, A2, Y2 the values. So we can calculate the Y bar, that is the center of gravity CG of the whole section from the base or reference line. So that the Y bar that equal to A1, Y1. A1 is 10,000 into Y1 is 225 plus A2 also 10,000 into multiplied with Y2 is 100 mm divided by A1 10,000 plus A2 again 10,000. If you calculate the Y bar value, we will get 162.5 mm. So as per the calculation, this will be the Y bar. Okay, as per the calculation, this will be the Y bar value. Y bar means the distance of the center of gravity of the whole section from the base or reference line. It means that will be from here, the baseline to the CG of the entire section. This will be Y bar here. So now we will calculate the moment of inertia of the whole section with respect to the horizontal or x axis, which passes through the center of gravity of the whole. We calculated the center of gravity of the whole section, Y bar, that is CG from the reference line. Now we are going to calculate the moment of inertia of the whole section about x axis passes through center of gravity of the whole section. As we did in the center of gravity calculations, in moment of inertia also, we have to consider rectangle 1 and rectangle 2. We have to calculate moment of inertia separately with respect to the x or horizontal axis, which passes through the center of gravity of the whole section. Then finally, we will add to calculate the moment of inertia of the whole section about x axis passes through the center of gravity. So first we have to calculate the moment of inertia of the rectangle 1 about an axis x1 x1. That means this axis passes through its center of gravity of the rectangle 1, that is CG1, that means that x1 x1, that axis is parallel to the x axis. We discussed already the formula, that is IG1 with respect to the x axis for the rectangle b d cube by 12. So here we can take for the first rectangle b1 d1 cube divided by 12. The values, linear dimension b1, that will be 200. The vertical dimension d1, that will be 50 cube divided by 12. As per the calculation, we will get this value will be 2.083 into 10 power 6 mm power 4. Now we have to calculate distance of center of gravity of the rectangle 1, that is CG1, from x axis. It means that the perpendicular distance between these two axes, that is xx and x1. Here, from the diagram, from the reference line, the axis x1, that is a distance y1. Same, the axis xx from the reference line is at a distance y bar. Then what will be the distance between these two axes? That will be the difference between y bar and y1. Sometimes this y value will be more, sometimes y bar value will be more. So instead of subtracting the values, we will take the difference between y bar and y1. Okay. So here, this distance, that will be the difference between y bar and y1. That is actually the h1 value. Okay. So h1 equal y bar, the difference of y1, that equal to 162.5, which we calculated for the y bar, the difference 225. So the h1 value we will get 62.5 mm. Then we have to use the parallel axis theorem to calculate moment of inertia of rectangle 1 about x axis passes through the center of gravity of the whole section. As per the parallel axis theorem, I xx for rectangle 1, that equal to ig1 plus a1 h1 square. All the values here we calculated. So substitute the values. So here we will get, substitute ig1 value 2.083 into 10 power 6 plus a1, that is 10,000 into the difference between y bar and y1 for h1, that is 62.5 square. Then if you calculate, we will get 41.145 into 10 power 6 mm power 4. This is moment of inertia of the particular rectangle 1 about the axis xx passes through the center of gravity of the whole section. Now we have to calculate moment of inertia of the rectangle 2 about an axis x2, which passes through its center of gravity CG2 and parallel to the xx axis. Same way, here we have to calculate ig2. that general formula BD cube by 12 here. To specify that is the second rectangle, we will take B2 D2 cube divided by 12. But we know that the values are same, like 200 into 50 cube divided by 12. We will get the same answer, that is 2.083 multiplied with 10 power 6 power 4. Then we have to calculate the distance of CG of rectangle 2, that is CG2, from the axis XX. Same way what we did for the rectangle 1, while calculating H1 from the reference line to the axis X2 X2, or the center of gravity CG2, that will be Y2. From the reference line to the axis XX, or to the center of gravity CG of the whole section, that will be Y bar. So the distance between these two parallel axes, that is between XX and X2 X2, that will be H2. Okay, this we can calculate from identifying the difference between Y bar and Y2. Okay, so the H2, previously we calculated H1, the difference between Y bar and Y1. Same way here, H2 equal the difference of Y bar and Y2. Y bar value is 162.5, and then Y2 will be 100. Finally, we will get the value of 62.5 mm. Okay, then we have to calculate moment of inertia of the second rectangle about axis XX, which passes through the center of gravity of the whole section. The same way what we did for the rectangle 1. IXX rectangle 2, IG2 plus A2H2 square. And here IG1 value, IG2 value also same, and H1 value, H2 value also same, and A1, A2, that value is also same. So the IXX rectangle 2 also we will get the same value like what we get in IXX for rectangle 1, that is 41.145 into 10 power 6 power 4. So now we have to calculate moment of inertia of the whole section about XX axis passes through the center of gravity of the whole section. That is IXX equal to IXX of rectangle 1 plus IXX of rectangle 2. Here actually both the values are same, like 41.145 into 10 power 6 plus 41.145 into 10 power 6. If you add both the values, we will get 82.291 into 10 power 6 mm power 4. This is the final answer of Ixx. It means that the moment of inertia of the whole section about x axis passes through the center of gravity of the whole section. So finally, we will recall whatever we discussed as of now. Here, actually, we have to calculate the moment of inertia. So first, we calculated the center of gravity. We split into two rectangles, rectangle 1 and rectangle 2. We calculated the individual values. Finally, by using the y bar value, we calculated the center of gravity of the whole section. That y bar means the distance from the reference line. The reference line is the line, the bottommost line of the whole section. From the reference line to the CG, center of gravity of the whole section, that is y bar. Then we calculated the moment of inertia of the whole section about x axis passes through the center of gravity. For this also, we split into two rectangles. First, we calculated for the first rectangle with respect to x1 axis, that is IG1. Then we calculated the distance h1 between these two axes, xx and x1. Then we used the parallel axis theorem to calculate the moment of inertia of rectangle 1 about xx axis passes through the whole section. Okay, then we considered the rectangle 2. Here also, first we calculated the moment of inertia of the rectangle 2 about an axis x2, which passes through the center of gravity CG2 and parallel to the x-axis, that is IG2. Then we calculated the distance between the two parallel axes, H2, same way what we did here, between the difference y bar and y2. Then finally, we used the parallel axis theorem, Ixx, to calculate for the rectangle 2. Here the dimensions are same, so we will get the same answer. Then finally, first we did for rectangle 1, then for rectangle 2 to calculate the moment of inertia with respect to the x axis passes through the center of gravity. Then finally, we add both the values, then we get the final answer. Okay, guys, thank you. Don't forget to subscribe for more videos. Thank you.